Hey everyone, welcome to Newegg TV. My name is Paul. Today we have a special guest. This is Oguzhan from NVIDIA. He's a senior product manager and he works primarily with the Quadro series of video cards. And welcome. Thanks for coming.
Thank you very much. Thanks for having me.
Yeah, and can you tell us a little bit more about what you do with NVIDIA?
Sure. I'm a senior product manager in the Professional Solutions Group at NVIDIA. I am primarily responsible for the higher-end Quadro products as well as the Tesla compute products.
Okay. And for those folks out there who might not be familiar with Quadro, let's at least start with the baseline. So what is Quadro? And people might know NVIDIA for their video cards, gaming graphics cards, of course, very popular. Quadro is not exactly gaming, but they are somewhat related.
Yeah, I mean, they are basically utilizing the same GPU architecture, although the chips are different. Quadro is our basically product line that is primarily targeting the professionals out there. In the manufacturing space, in the oil and gas space, in media entertainment, in medical imaging space. We're going to talk about those a little bit more in detail in a few minutes. But if you don't mind, let me talk about the ecosystem for Quadro, if you will.
Of course.
So over the last 10+ years, we have built a huge ecosystem. Basically, Quadro is not just a GPU anymore. It's not just an accelerator anymore. Mm-hmm. We have application acceleration engines such as iRay and Optics that are ray tracing engines I'm going to talk about. We have, on the sales side, we have enterprise sales, enterprise support team, as well as the solutions architects team. So all these people work with our end users directly, one-on-one, to help them build custom solutions, such as synchronized display walls or some customers in the broadcast space. Some of the typical features of the Quadro and Tesla product lines are the ISV certifications. I couldn't highlight this one enough because many professionals, I mean, the software and the hardware cost a lot of money for engineering firms, for design firms, and these companies, they want their hardware, their platforms to be stable. And in order to enable that, we actually work with software vendors very closely before our products come to market to make sure that our products are certified. What that means is that we go through a whole a few months, maybe more, depending on the product and the software, of certification. We find bugs, we resolve them. The drivers are updated. We make sure that the product, when it's launched, it's actually stable. So that's one of the reasons why Quadro products, Tesla products, they typically tend to go to market slightly behind the consumer products.
And we've seen the 600 series out for a while, and this is based on that same Kepler architecture that the 600 series is based on. This is the card that you have brought for us today is the K5000.
That's right.
And from my understanding, that's really one of the primary differences from going with the consumer grade versus enterprise level cards is they're designed, they're built entirely by NVIDIA, they're validated by NVIDIA, and you guys work directly with independent software vendors to make sure that when the cards are installed, they're going to work and they're going to work well. Right.
Absolutely. Yeah. So K5000, the Quadro K5000 is our new product in the Kepler family of GPUs, the first one we're coming out to market with. It's going to be available in October timeframe. As I mentioned, all the ISV certifications, etc., they will all be complete or close to complete by that time frame, so that the product is fully stable on many of the applications that we target. Again, just to give some examples, in the manufacturing space, typical applications are like CATIA from Dassault, SolidWorks. These are all target CAD applications, just typical CAD applications for this particular product. It's a high-end product. It's a sub 150 segment for us, if you will. And one of the things that differentiate this product compared to the consumer products, if you will, is the memory size. A lot of our customers work with large data sets, complex data sets, and they want to be able to interactively work with their data sets. And this card basically enables that. The data set actually fits into the GPU memory. The GPU is strong enough to be able to handle the complex data sets very well. That's why we have been targeting these higher-end CAD applications, if you will, for this particular product.
And that large memory capacity. So, for instance, if you have a 3D application like this with a model, the more complex that model is, the more memory is necessary to load that.
Correct. Yeah, this particular application we're going to demo in a few minutes is shot by Bankspeed. It's a pure ray tracing application. And it's just ray traces a frame basically, but you need an actual design application to go along with this. Typically professionals use, say, SolidWorks, for example. They've been designing this particular model in this case. It's a certain number of polygons, in this case it's about 720,000. You import that into Bankspeed, the shot application, and then they ray trace it. The main reason this particular application is used is for creating marketing material, or maybe design reviews in the initial stages of the design phase for automotive company or any other company that does these similar designs, if you will.
And with ray tracing, I'm sorry to interrupt,
Sure.
With ray tracing you can actually get like pretty much lifelike representations of the 3D model. So if they're using that for marketing or whatever, you need a picture of that model, and with ray tracing you can actually take a virtual picture of that product without even having a physical version of it?
Absolutely, yeah. So as I mentioned previously, the application acceleration engine, the iRay, that is an NVIDIA product, it's a pure ray tracing engine, and ray tracing, as you mentioned, is used solely for the purpose of creating physically correct renderings of any image, of any model. It is used in applications such as Bankspeed. It is in CATIA from Dassault in a live rendering module. It's integrated into the application. It is in Autodesk's 3ds Max in the 2012 and newer. And other CUDA-based ray tracing engines are also built by different companies, third-party companies, but they're not necessarily iRay-based. iRay just makes it easy for any ISV software vendor to take from NVIDIA free, license it, and then integrate into the application. It becomes a push-button ray tracer. I mean, in this case, we can, if you want, we can just demo it right now, real quick. So this is a model imported from SolidWorks. And then I didn't go through the process, but you basically turn ray tracing on.
So with ray tracing off, we're getting sort of a pre-rendered version of it. It's not going to be 100% accurate, but then you turn the ray tracing on, and this is actually mapping like photons, like the actual light going in, hitting the object, bouncing off, refracting, changing that, and then hitting the virtual camera to give you this image. Correct.
Yeah, iRay is basically a physically correct rendering. So it's simulating the light rays. Basically, it's path tracer. There are millions of rays that are bouncing off of surfaces in this case. The more complicated the model is, the harder the problem is for the processor to solve. That's why the CPUs in this case is very they're not necessarily efficient. This is a very embarrassingly parallel problem, if you will. So you want to be able to distribute all of these rays that are being simulated to thousands of cores on the GPU. In this case, we have a single Quadro K5000 in the workstation. Imagine if you added more Tesla cars to it, the Tesla K20 cars that we recently announced back at SIGGRAPH. They are going to be available shortly as well. You basically add those on top of the Quadro card in what we call a Maximus configuration, which I can talk about it separately as well, to enable almost real-time ray tracing. In this case, as I'm sure your viewers seen, it takes a little while. When you have a single GPU, ray tracing takes a while for the image to perfect, or to get to a perfect rendering, if you will. So if you don't want to wait that long, you want it almost instantaneous or almost real-time performance, you want to be able to add more GPUs to your workstation. Ray tracing is a problem that can scale in performance with the number of GPUs, the number of cores you add to your system.
And just to clarify for our viewers, the Quadro cards, like the ones we have here, those have video outs, if you will.
Yes.
The Tesla cards are more like you get the GPU in there, you get the GPU compute capabilities, but they're headless. So essentially, by adding more of those, it's like you're expanding your the amount of work that it can handle.
Right.
But then you do need a video out card as well.
Right.
Okay.
Yeah. So that's talking about Maximus a little bit. It is a technology that we, or technology/platform that we just recently announced. Well, it's been a year, about a year. It basically, from a hardware perspective, it's the combination of Quadro and Tesla cards in the same workstation.
Okay.
At least, actually I should say, at least one Quadro card and at least one Tesla cards in a system, depending on the user's needs. Quadro is basically going to be responsible for running the 3D application, whether it be a CAD application or another media entertainment application. It's basically a design application, let's say. And then Tesla cards will be used for the compute applications. In this case, it's a great example. SolidWorks is being run on the Quadro card, and then you import that model that you designed on Quadro card into the into bank speed shot application, and you kick off ray tracing. Because ray tracing is a compute application, it starts on Tesla card, and then it's up to the user whether to enable Quadro as well as a compute device or not. Because depending on the interactivity you want from your system, you want to enable Quadro as a CUDA device or not, if that makes sense.
So you can sort of assign where you really want that GPU compute load to
yes.
Whether you want it to go mostly on the Tesla cards or mostly on the Quadro cards. Of course, a single Quadro card could handle all of that. It's just a matter of what type of application you're working with, the complexity of the models you're working with. You might want to add Tesla cards as well as that to be able to handle it all at the same time.
Yeah, one thing I should clarify is that a GPU is a single pipeline, right? You cannot do two things at the same time.
Okay.
You cannot do graphics and compute at the same time. If you would like to do them concurrently, simultaneously, then you want to have two cards. You want to have a Quadro and Tesla. And you want to disable Quadro as a simulation device or a CUDA device. So Tesla runs the compute application, such as ray tracing, and Quadro runs the visualization application. Okay. So they can run simultaneously.
We've been talking about some of the implementations of this. Let's talk about sort of the customers who might be interested in Quadro cards or Tesla cards or the Maximus platform in general. What other types of applications, what types of customers might be interested in these devices?
Sure, especially with this type of high-end card like the Quadro K5000, the primary industries that we are selling into are manufacturing, media entertainment, oil and gas, medical imaging primarily. There are a few others too, but these are the primary industries. In the manufacturing space, ones I've already talked about, like the high-end CAD tools, SolidWorks, CATIA, and especially for customers who have complex data sets, the ones who need the GPU's horsepower, not only for graphics, but also for compute, and also the large memory size. In the M&E space, or actually I should say in the product styling and design section in the manufacturing space, that's where the applications such as bank speed are used. Because certain, even enterprises or SMB customers, small to medium-sized businesses, they use applications such as this to be able to do design reviews. And they do multiple iterations, right? So they go back to SolidWorks, they make a design change, come back in here, do a physically correct rendering, see how it is. If they like it, that's great. If they don't, it has to be an iteration, right? Okay. And that's on the manufacturing side. On the media entertainment side, like Adobe's the Creative Suite, for example, is a great typical example.
We use that.
We use that. Quadros are used as well as our consumer products, of course. But depending on the user base, if you have higher end needs, if you're working with multiple layers of HD content with multiple effects, high-end effects applied to it, using Premiere Pro with the Mercury Playback Engine, or After Effects in the CS6 now has optics ray tracing as well. The same functionality that you're seeing here is now built into After Effects, for example. You can ray trace extruded 3D text. That is brand new, and Adobe is also marketing that quite heavily. That's where you need Quadro or Quadro plus Tesla Maximus configurations. It's just one example, and basically post-production, if you will. In the oil and gas space, in seismic interpretation, that's another place that we play a big role with these high-end cards. And lastly, medical imaging.
So now we talked a bit about the implementation as well as a lot of the software and use cases for this card. Let's take a closer look physically at the card itself. This is the NVIDIA Quadro K5000, which is the new version of the NVIDIA Quadro 5000, the Fermi-based card. And we're going to do a little comparison chart here in just a second, but first off, closer look at the card itself. This is, I would imagine, PCI Express Gen 3?
Correct.
All right. At the back here, we have 4 independent display outs. We have 2 dual-link DVI connectors. We also have 2 full-size DisplayPort connectors.
Correct.
I like the full size.
One little detail I'd like to give there is one of the DVIs is DVI-D, the other one is DVI-I.
Oh yes, actually.
So there's only one analog and out from here.
All right, so the lower one here has the analog connector points there, so if you're going to use an adapter to a VGA monitor, which I guess some people might still do with Quadro, use the lower one. And then there's actually a lot of different ways that you can set up the display outs for this, because I know these cards are a bit more in the enterprise space, so you might be looking at some pretty high-level resolutions, so 4K resolutions, for example, and you were showing us a chart where you can actually take both of the dual-link DVI connectors.
We can look at that real quick.
And you can connect them to support a 4K resolution screen.
That's right. So there are different uses, like in the Fermi cards, Fermi-based cards, which is basically the current lineup on the Quadro side, is 2 display out, right? So even though there were 3 display outs, like physical connectors on the bracket, 2 out of 3 were active at a time. With the Kepler-based Quadros, you're going to have, at least on the higher-end ones, there's going to be 4, just like you see here, and all 4 will support 4 independent outputs. And there are different use cases. You can you connect 2 DisplayPort displays to each of the DisplayPorts you see over there. And to run a 4K display, for example, 4K resolution displays, you can use 2 of the dual-link DVI connectors for each side of the display. And again, DisplayPorts can be connected to separate 4K, since DisplayPort by itself, just a single one, can support a single 4K.
I get asked the question a lot of why DisplayPort and not HDMI. That's a really good reason right there. DisplayPort has a lot of bandwidth.
Exactly. Yeah. And the one nice thing about DisplayPort, now you mentioned about it, is daisy chaining. So once the daisy chaining enabled displays are available, which are basically DisplayPort 1.2 spec compatible, you'll be able to take advantage of that. So from a single DisplayPort, you'll be able to daisy chain 4 independent displays.
Okay.
So that's one of the advantages with DisplayPort 1.2.
Let's just continue with our sort of physical look at the hardware here. So if you guys are looking at the back here, and you maybe have seen some of the GTX 670, again, that's on the GeForce side, but those card designs, it has a very similar design here. It's got a shorter PCB, a longer blower-style fan with the shroud that extends out to the end there. Benefit here in a workstation environment is you're going to be pushing a lot of that hot air out the back of the card and not going to be contaminating the inside of your case with the exhaust from the card. Also here you can see a lot of the memory modules on the back. Again, the higher memory capacity is one of the great features of this card. And then something that some folks might here be seeing and thinking, those are SLI connectors. The SLI, the connectors here actually function a little bit different way with the Quadro cards than people might be familiar with the GeForce. Right,
so SLI is for Quadro, Quadro land, if you will, is used very differently from GeForce.
Okay.
The primary benefit really is to be able to scale displays. With SLI, 2 of the SLI Quadro K5000s, you can get up to 8 synchronized displays. And through SLI, you can actually get what we call a mosaic mode.
Okay.
Basically, this taskbar extended all the way across, however many displays you have vertically, let's say 4x2 setup, let's say. All 4 of the displays will have that extended taskbar extended, basically. Okay. And then you can span an application from a single display to all the 8 displays, and you will see no performance loss.
Excellent. And then one other connector down here, this little 4-pin guy right there. And
right.
What is this?
So that is the users of the prior generation Quadro cards will recognize that on the bracket there's one connector missing right now, which is the 3-pin mini-DIN connector. So that's been the de facto standard on the higher end Quadro cards for dedicated connector for supporting 3D stereo displays.
Okay.
One of the advantages of that, that connector is basically you're not relying on the system resources, in other words, USB support within the operating system for 3D stereo support. Okay. If system gets too busy and it may not able, you may see some, let's say, interruptions on the 3D stereo support on the display because you're supporting through USB, as opposed to a dedicated 3D mini-bin port on the bracket on the Quadro cards to support the 3D projectors or displays.
Okay.
So we took that connector out on this generation because now we have 4 displays, so the 4 display outs on the bracket. But it's not here. I don't have it with me right here. But it's a 3D It's a separate bracket that has that connector.
Okay.
Connects to this little 4-pin connector.
All right, and that's pretty much it as far as our close-up look at the card. Did you want to point out something?
Yeah, two more things actually.
Sure.
One is on the, as far as the connectors are concerned, these are, one of them is actually SLI, because you can do SLI on the Quadro with only 2 cards.
Okay.
And the other one, as it's seen here, is it support SDI and sync.
Okay.
Basically, what I talked about earlier is we have a separate sync card to synchronize multiple displays. You basically connect that here, or SDI is another solution for the broadcast space.
Okay, and so that would provide you with, for instance, SDI out, which is much more of a standard with professional video.
Correct.
Okay.
Yeah. So that's even though it's a live finger, that's dedicated to that. That's why. That's hence the marking. And one more thing, I guess, is from a hardware perspective, K5000 requires only a 6-pin auxiliary power.
And that goes to the efficiency of the new architecture, the Kepler architecture, and that's also actually one of the things when I first took a look at this card that kind of surprised me was only one 6-pin, and that speaks to the efficiency of the architecture.
Right.
And I think we have some information on that as far as the power draw.
Yeah, this card basically draws 122 watts. One of the, as you mentioned, one of the key things for us to focus on with Kepler was performance per watt.
Mm-hmm.
And you see that on all of our Kepler products that we announced. And Quadro is no exception. Quadro 5000 versus Quadro K5000, you see 152 watts versus 122 watts, of course with increased graphics and compute horsepower.
Mm-hmm.
To look at other specifications on the Quadro K5000, number of cores are higher, even though they are not necessarily apples to apples. We should clarify that.
Mm-hmm.
This is the Kepler architecture. The memory size is going from 2.5 gigabytes to 4 gigabytes. Memory bandwidth is increasing as well. The gigaflops from a compute perspective, from a theoretical peak perspective, it's 3x the Fermi card.
Okay.
But it's going to, the performance is going to change from application to application, of course. There's ECC support. The brackets, we talked about the displays already. I talked about the Displayport 1.2, the multi-streaming, and display synchronization as well. There's a new sync card, Quadro sync card, that is coming down the pipeline as well. That is going to be dedicated to only to the Kepler cards. And you can actually support up to 16 displays from a single system, all synchronized. Quadro SLI we talked about, and SDI GPU Direct for video we talked about.
Excellent. So there's a nice comparison between the Fermi Quadro 5000 and the new Kepler-based Quadro K5000.
Right.
And of course, we do want to at least give some comparison numbers here. So we have some benchmarks using ViewPerf 11.
Right. So ViewPerf 11, for those of our users who don't know about it, is basically 3D Mark for GeForce, if you will. So 3D Mark for Quadro, if you will.
Okay.
It's a de facto standard benchmark. Of course, the synthetic benchmarks, and majority of our customers, they should run their own benchmarks internally with their own data sets, and because they vary, the results will vary. But this is a great tool for showing the performance delta that they can get in each application. ViewPerf 11 has 8 different applications in it that it tests: CATIA, Nsight, Maya, ProEngineer, SolidWorks, Team Center, Siemens NX, and Lightwave. As you see, this is comparing N-2 generation FX 4800, 5000 to K5000. I put in the years here, so if a customer bought an FX 4800 based system, for example, say 3 or 4 years ago, I mean, typically what we find is that our customers refresh their systems in about 3 or 4 years or so. This is the performance delta that they can expect for these applications.
And that's going to wrap it up for this video, guys. I hope you've learned a lot more about the new Kepler-based NVIDIA Quadro K5000 card, as well as a lot of information here that applies to the entire line of cards that are available soon, if not now, if not in the very near future. Does that make sense? More or less. Okay. I wanted to thank, we're now affectionately calling him Ozzy.
Sounds good.
Yeah, see, he's even okay with that. I'm Paul with Newegg TV. This has been Ozzy from NVIDIA, speaking on the Quadro K5000 video card. Thanks a lot to all you guys for watching. If you'd like to see more tech videos, you can check out our YouTube channel. That's youtube.com/Newegg, and we'll see you all next time on Newegg TV.